Class, yeah, the last video was bad, and so I'm reshooting this one. Hopefully this one's going to be okay. Anyway, what if I want to do it myself? Well, what is it that I need? Well, first I need an idea. I'm trying to make a prototype. I need a place to work. And I need tools to be able to put it together. So in terms of space, well, a lot of startups start in garages, so it doesn't cost you anything. There is such a thing called share space, where you can actually buy office space in places. So they have meeting rooms, and you have printers and things like that, and you get your own little desk or cubicle. Typically those are about $50 to $200 a month. Warehouse office space here in the Phoenix area is about $1 to $2 per square foot per month, and if you want to use chemicals, which means you need a concrete floor or something like that, that's going to cost you a little bit more. But as you can see, very affordable, not like Silicon Valley where it's like 10 times as much. Now, one of the problems I might have is, what if I need expensive tools like CNCs or lathes? Universities are actually really good places because what they do is rent out their time in their labs. So there's this fear about, oh, what about intellectual property? If I do it on, a university's equipment, do I lose it? And the answer is no, because what happens is when you pay for lab time, you're actually renting the space. So it belongs to you and you don't have to worry about that. In terms of software, what if I want to do it myself? Lots of opportunities, lots of books. Udemy courses have become highly recommended. There are websites. They want you to learn how to code because they want you to be an active user. And of course, you can take classes because you're attending the #1 innovation school in America. Now, Dr. Cho has a background in chemistry, electrical engineering, and mechanical engineering, as well as physics. But here is the secret about how all physical technology works. First of all, there's some governing law that's probably derived from Maxwell. In order to solve a differential equation, you need the boundary conditions. Once you have the boundary conditions, you can solve any problem. And where they come from is design pretty much defines what the dimensions are, what materials you are going to use, define the constants, and then you're going to perturb the system, meaning you're going to bend something or you're going to apply a voltage or something like that. So how does it respond to this perturbation? And so that's the solution of the differential equation. But here's something that's interesting. A lot of engineering is about grinding in math. You don't have to do the math anymore. There's simulators that'll do this. So what it comes down to is the big separator is problem solving. The thing about a classroom is it's basically a very well-contained environment. Doing entrepreneurship in a classroom is like a fish in a fish tank versus a fish swimming out in the ocean. Two totally different situations. And so what separates people on the outside is how the decisions that you make and how you solve problems. At MIT, Dr. Cho really struggled in classes. Yeah, he got an A when he worked his best, but it was pretty much a ham fight the whole way. Then I come out to industry and all of a sudden I'm doing fantastic. Why? Because it's not about doing tests anymore. It's about how creative you are. In mechanical engineering, what it's about design, it's about materials. How do I fabricate and shape things? Typically you'll have multiple components, so it's about assembly, and then I've got to test it. And so how do I get those mechanical options? Well, one question is, can I outsource this? Or do I need technical people? There's a company called Portable Therapeutics. It was actually funded by physicians who were all orthopedists and wanted to come up with better cooling systems for people who, after they had surgery. And what they did is they outsourced it. And so they were able to do it. Airbnb didn't bring on a software engineer for a year while they worked out everything with their business. Michael Dell, did he know anything about computers? Nah, he was a pre-med major. But Michael Dell understood the business. So as you can see, you don't need to be a technical person to be successful. The big thing about having people in-house and all is it impacts your speed and you own the IP. There's less questions about how that's worked out. In terms of resources, here's a list. If you want design, there's all kinds of free software. Actually, Autodesk is really good because when you're a startup, they pretty much give it to you for free. And then when you start making, then you have to start making money, then you have to pay. You can get vendor trials. There's a multi-physics software called Console. They'll give it to you for, if there's a specific problem you want to solve, then you can actually get it for free for a couple of weeks to try it out. In terms of parts, you could actually go on Amazon and buy a chunk of Teflon if you want to. Home Depot, Harbor Freight, those kind of places have machining and fabrication. Now I have Tech Shop written here. Tech Shop has recently shut down. They may reopen, so I'm just leaving it on there for now. And if you need advanced equipment, like shaker tables or something like that, again, universities are good places to find it. Those of you who aren't local to ASU, you probably have some university close, physical university close to you that you can use. And electrical engineering is about computing, communications, circuits, integrated circuits and sensors, and coding. So in terms of electrical design, I need a circuit design. I need to populate a board once I have that design. There might be some coding I need to do. In terms of testing, you could do it yourself. You could use something called a RIO, which I'll show in a little bit, or labs. And there are tons of publications that'll help you and tell you how do you go about doing this. The one thing about the IEEE, they are the biggest trade association in the world. They have 425,000 members globally, and they have 39 different societies. So you can look at their publications to learn about specific topics you might be interested in. Not only that, vendors are a fantastic place to learn. Why? They want to teach you. They want you to be using this stuff. DigiKey, Newark, there are a couple of these that are pretty big component suppliers. Well, what a BOM manager is a bill of materials, meaning everything you order for them, they'll tell you how much it's going to cost. And so you automatically know the cost of parts without you having to make any have any problems. The other aspect is design. They give you designs. Why? Because they want you to buy parts to make those designs. Here is an example of an accelerometer. The nice thing is they actually tell you what the price breaks are, so you can see what kind of discount you're going to go ahead and get with volume. And so you can actually plot this and figure out what it's going to look like if I want like 100,000 pieces or something like that. But for $1.36, you can get an accelerometer. And they give you the data sheets. This is actually for a gyroscope. And guess what? You don't need to figure out the circuit. They give it to you. They tell you how the whole thing works. You don't need to know anything except how to solder and build the board. Well, what if I have specific designs? Like I want to control a motor, or I want a wireless communication. Well, Zigbee is a wireless module. And motor controllers, again, they give you the circuits. You don't have to do anything. Somebody's already done the project for you, and they want to share it with you. This is why those network groups are so good. They want to encourage you to talk to each other. Now, what about, eventually, I'm going to need some kind of interface to software. There's something called LabVIEW in National Instruments. Granted, it's not very pretty. However, what it's really useful for is prototyping. So you can show someone, then later on you can make it pretty. But it uses what's called a graphical language. Meaning, well, I don't know how to code in C or anything. You don't need to. All they do is have a bunch of templates, and you just put it on a screen, and then you wire it together. So the example given here is, supposing I have a piece of machinery, and if the power gets too high or the temperature gets too high, I want it to shut down. And so what happens is you just pull out these polygons, wire them together. So based on the measurement out there of the power threshold, it compares it to some limit you give it, same thing with the temperature, and then it compares it together, and then if it gets too high, that red button there means shut down. Again, not very difficult, very easy to learn. There are also test modules. This is called the RIO. All the voltage supplies, or if I want to read data or something like that, all built into this nice little modular unit. Very convenient. It's made by National Instruments. Most of engineering and hobby labs you can find it in. What if I want a prototype? Lots of sources for it, laying out circuit boards, buying parts. Everything is out there for you. Now, what if I want to do chemistry? Well, chemistry is about materials. You can order materials. There are lots of vendors out there, Sigma Aldrich, J.D. Baker. If you need a chemical bench, all a chemical bench is a hood. You can buy one used or make your own. Infrastructure. That's Dr. Joe. I actually have a full set of chemical things. Once I found mold in the basement of my cabin, and rather than hire somebody and pay them $500, I mean, I had the whole suit, I had the gloves, I had my own respirator, I did it all myself. And again, you can get university time, and if you have waste, you can call somebody to recover it. Here's a little tip from Dr. Cho. If you have organic waste like acetone or alcohols or something like that, typically you're using very small quantities. You could just leave it sitting outside and just let it evaporate into the air, and then you don't have to worry about the waste. It's a small enough amount that you're not under OSHA rules, so you don't have to worry about it too much. In terms of computing, a lot of you are probably familiar with Raspberry Pi. Well, Raspberry Pi is the processor that's equivalent to your phone you can just purchase. You could buy a Raspberry Pi used for $10. For $90, you could buy the kit with the shell. You too can have computing. Now, can anybody do this? Well, here's an example. My goddaughter, actually I couldn't find her picture. That's a daughter of my granddaughter. But anyway, she was a history major, and this was in the 1990s, before they had all this fancy schmancy stuff that they have today. And she was afraid of SIDS. She wanted to know if her baby rolled over. And she said, well, and I said, oh, that's pretty easy. You can make something with pressure sensors, and then you can have it alarm or light up or whatever. She said, can you make it for me? And I said, no, I don't have time. And then she started flying expletives towards my direction. But anyway, I told her that she could do it herself. And so she did some reading, and I gave her a little coaching. She bought pressure sensors. I taught her how to solder. You know, how difficult is it? This heats up. You take the solder, melt it together. Oh, look. She followed the application notes. She made her own boards. It's like, oh, look, I have to buy a capacitor. And so on this board, I soldered together a capacitor. And she made it a little fancier. She put a light on it too, and she had a beep. And so she made her own system. And what it came down to is she had the will to do it. That's what this is all about. If you need people that you need to work with, there are all kinds of sources, whether you could try trade associations, websites. Actually, ASU, you can post a job ad if you're local. And if you need to find specialists, or there's a topic you're interested in that you read in a paper, contact the author. Actually, if you look at patents also, that's another source. Now, what about my intellectual property? What about that? Well, if they can reverse engineer it, meaning take it apart and see what you did, patent it. If they can't, then make it a trade secret, like Coke. Dr. Cho had a process that raised the yield from 99% to 99.999%. Now, you don't think that's a lot, but it's actually quite a bit. You're talking about when you're making 100 million parts, all of a sudden 1% is a big deal. That's 1 million parts. And if you're selling them for $50 a piece, that's $50 million. But I got the yield up there quite simply because I found out that if I rinse something only for 10 seconds, I actually prevent a lot of surface damage. And it's extremely subtle. There's no way on earth they would ever figure out that that was my secret. So I trade secreted. I didn't patent it. Because if you patent it, then what ends up happening is it becomes public domain. Well, how am I going to police them rinsing something 10 seconds? So in summary, there are plenty of resources out there. What it comes down to is, do you have the will? You don't have the background, but if you have the willingness to try to do something, you can get there. And finally, it depends on your attitude. There's no I can't in entrepreneurship. At one startup, somebody said to me, I can't do this. I said, okay, that's it. Everybody go home. And everybody was kind of frozen, was shocked. And I said, look, if your answer is I can't, then that means that this startup can't make it and we should all just give up and go home. And so, once again, it all comes down to what your will is. If you want to do it, you can do it. There's no I can't in entrepreneurship, but there is a preener in it.